In this video, we'll continue our discussion of domain of higher dimensional graphs. So here are domains. So they want us to graph it. The domain, let's find what that is dimension-wise. So if we're looking at our function, we have an x, a y, and a z. So this is a 3D domain, which means I would get x, y, and z, and then I'd have a fourth for the output, which puts me a 4D graph. So we're not going to graph. It doesn't even make sense to graph the graph in a 3D plane. We're just going to graph the domain. Okay, so how I do this is I start looking at the domain. Okay, I have that inside of my radical. I got 25 minus x squared minus y squared minus z squared. And we know this can be greater than, it has to be greater than or equal to 0. Can't be negative. If I move my x and y squared and z squared over, right, I get all that is less than 25, right? Hopefully this rings a bell. This is a sphere. It's the inside of the sphere. It's like a whole solid sphere with a radius of 5. All right, so we're going to do our best to graph this. I know mine won't look great. Yours will probably look better than mine. So I'm going to put 5 in each direction. And then what I try to do from here is I create circles, which is going to be a bit difficult because it's a bit off. Let's see if I can. There we go. Mine's not going to be the best looking. So that is the circle that should be living on the XZ plane. Here's XY plane. All right. And we'll make dotted lines to help us out with dimension here in a moment. This doesn't have to be the prettiest because obviously mine is not. Right, so that was the circle that lives in the XY plane. We did XZ plane. Now we got to do YZ plane. So here, here, there, back to the top. Looks so good. My sketch looks better than this in my notes. So let's go ahead and make some dotted lines here. So I'm going to erase partial on, let's make this a little bigger. Okay, so this is back behind. So we have this front piece here. All right, and then we have this piece that's the front. And then we also have the outside one that is the outside sphere here, or we can actually make a round circle here. It's not the greatest. Okay, so there is my attempt at a sphere. We could do dotted lines in the back to try to make it better. All right, there's that one. Yeah, I'm not doing it justice, but hopefully you can see a sphere. If not, that's okay. So with that, know that you will never be graded on your artistic ability. I will find ways to ask graphing questions that won't require you to do a sketch, or a multiple choice sketch question, something in like that. Multiple choice or something that won't require you to be artistic, because obviously I can't do it very well either. So there's my sphere. What does this mean though? What this means is if I pick any point on the sphere, right, in the sphere or on the sphere, it will be a point that I can plug into this function. So if I pick a point outside of the sphere and I try to plug it in, I'm going to get the square root of a negative. So the whole point of the sphere is this is the collection of all the points that will give me an output on my 4D graph. I know that's kind of weird, but this isn't the graph, it's the domain. Everything in the sphere is an input for my function. All right, so we could write domain here. Domain are all x, y, and z. Oops. Such that x squared plus y squared plus z squared is less than 25. And that's the solid sphere there. All right. Let's get another rep of this. All right, we have this function, domain of that. So first thing you should do is identify, okay, well, this is a, I have an x, y, and a z, so it's a 3D domain. but a 4D graph because I have X, Y, and Z and then the output. Okay, so we got to start figuring out what parts should be there and what parts should not be there. Let's take the inside of the radical. I know those have to be greater than or equal to 0. So if I move my x squared and y squared to the other side, I get this equation. Okay, so this is a circle on the xy plane, but remember, if I'm missing a z, then it's a cylinder, right? I get all the z's. So I'm going to go ahead and that is a radius of, it's not pretty in this case, it is the square root of 5. Square root of 5 is a little bigger than 2, so we'll just do our best. So a little bigger than 2. We get a circle there. So do my best to draw a circle. Circle from a different perspective. All right, so I'm going to cheat now, and I have a cylinder, so I'm going to duplicate this. You'll just have to redraw it. All right, there's that. And then I connect my points. Just do it straight down. There we go. All right, and then this point here. Oops, okay, so let me straighten this out. There we go. All right, and then we would have a dotted one maybe on the back to represent that back side. I'll just do a straight down one right there. Cool, it's locked. Okay, so this cylinder is, let me get this locked straight. There we go. So it's a cylinder straight up and down. I'm going to go ahead and shade this. So our whole domain, for a moment, we got to do something else. Right now we're looking at the points that are inside. Let me make this bigger. Oh, it's maxed already. Okay. All the points inside the cylinder, as of right now, we got to look at something else. But these are the points that potentially could be used inside my function. Everything outside of this cylinder will not work. It will give me a square root of a negative number. All right. Sorry, my coloring's not the best. I'm not trying to be perfect in the lines. There we go. Ignore that little double spot. Actually, I can just get rid of that. There we go. So this is the cylinder, but we have another part that we have to consider. So this was that part. It's fine. The next part was z squared minus 4 cannot equal 0. If I were to follow this algebra, I get z cannot be plus or minus 2. Now, what does this mean? Z equals 2. X and y are gone, so I get all of x and y. So what we're actually going to be taking out is we're going to take out a whole plane. So I'm going to take out this whole strip. Let me do it in white right here. That whole strip right there is going to be, not right there. Let's do it at 2. So at 2, right, we get this taken out. So you have a whole, like it's the whole cylinder except for this whole sheet is gone right there. We also have one for negative 2. That whole sheet as well is gone. So what does that mean? I can pick any point in that cylinder as long as the z isn't 2 or negative 2. So you get that whole big cylinder except for missing a whole slice at 2 and a whole slice at negative 2. All right, so that is our domain. It is not the function. This function is 4-dimensional, meaning I can't really graph it the way it stands. We'd have to think of a way to represent a 4D graph. So we'll stop there.